When you think about what makes an application truly great, it's not just that it works, it's that it can survive when things inevitably go wrong. Today, we're going to pull back the curtain on one of the most powerful tools for building exactly that kind of resilience: Amazon Route 53 Health Checks. Okay, I want you to picture this. It is 3 o'clock in the morning. Your phone starts screaming with a high priority alert. Your most critical application, the one that makes the money, is down. You feel that cold pit in your stomach. What do you do? Well, for a lot of people, what happens next is this all too familiar manual panic drill. You're awake, you're scrambling, trying to figure out what broke, where it broke, and how on earth to fix it. You're probably trying to SSH into a server, restart a service, and then the really slow part. You have to manually update your DNS to point traffic somewhere else. By the time it's all over, your users are angry, and you are completely wiped out. So you've basically got two paths you can go down here. The manual path is slow, it's stressful, and it is just begging for human error. But there is another way, an automated, hands-off approach that can recover from a failure almost instantly. And that is what we're here to talk about. Okay, so how do we get from that manual panic to automated peace of mind? Well, the answer lies with our automated watchdog, the Amazon Route 53 Health Check. So what is a health check, really? At its heart, it's actually incredibly simple. It's just a process where Route 53, from all of its locations around the globe, sends automated requests to your application just to make sure it's alive and kicking. You can think of it like a constant automated pulse check on your app. And here's the cool part. It's not just checking one simple thing. A health check can monitor 3 completely different kinds of status. It can directly ping a resource, like your web server. It can monitor a whole group of other health checks, and it can even keep an eye on the status of a CloudWatch alarm. Let's break down how each one of these actually works. Now, to really get our heads around these, let's use an analogy. I want you to think of your application's health like it's a hospital emergency room. You've got different levels of monitoring going on, and believe me, Route 53 has a check for each one. First up, we've got the endpoint check. This is your triage nurse. Their job is to go right up to the patient, which is your server or your application endpoint, and check its basic vitals. Are you responsive? Are you okay? Simple as that. So how does it actually check those vitals? Well, this is where it gets pretty specific. For an HTTP or HTTPS check, it's not just about getting a response back. It has to connect within 4 seconds and then get a successful status code, like a 200 OK, within 2 seconds after that. For a TCP check, it just needs to make that connection within 10 seconds. It's a really direct, clear-cut test of whether your application is available. But hang on, you might be thinking, what if the internet is just a bit flaky in one part of the world? I mean, a single health checker might not be able to reach your server, but that doesn't mean your server is down, right? Exactly. And to prevent those kinds of false alarms, Route 53 has this really crucial rule. It considers your endpoint healthy as long as more than 18% of its global checkers say it is. This builds in a ton of resilience against regional network hiccups. Okay, let's move on to our second type, the calculated health check. This isn't the triage nurse checking on one patient anymore. No, this is the charge nurse. They're worried about the health of the entire ward. They need to know if, say, enough servers are online to handle the incoming patient load. See, a calculated check doesn't monitor a server directly. Instead, it monitors other health checks, and it can watch up to 255 of them. You're the one who defines the rule for the group. So, for example, just like we see here, you might decide your whole application is healthy as long as at least 3 of your 5 web servers are passing their own individual checks. This gives you that awesome, high-level charge nurse view of your whole fleet. And finally, we have the CloudWatch alarm check. Now, if the endpoint check is the triage nurse and the calculated check is the charge nurse, this one's like monitoring the hospital's central oxygen supply. This isn't about one patient or even one ward. It's about a critical piece of infrastructure that affects absolutely everyone. If this thing fails, you've got a much, much bigger problem on your hands. This type of check is really smart because it monitors a CloudWatch metrics data stream directly. It's not just sitting around waiting for an alarm to go off. No, it's looking at the underlying data for things like a spike in your database error rates, or maybe the number of healthy hosts behind your load balancer dropping dangerously low. It's your early warning system for those big systemic issues. So we've got these awesome automated watchdogs constantly checking our application's health. But, monitoring is only half the battle. Just knowing something is broken isn't enough, right? The real magic, the whole point of this, is what happens when a check fails. This is the automatic recovery part. So let's walk through a super simple setup. We've got two web servers, Server A and Server B, and they're both happily serving traffic. The health checks are running, everything's green, all systems are normal. And then, boom, it happens. Server B stops responding the way it's supposed to. The health check that's watching it fails its vitals check. Immediately, Route 53 marks that endpoint as unhealthy. And here it is. This is the whole ballgame. Without anyone lifting a finger. No frantic phone calls, no manual DNS changes. Route 53 simply stops sending traffic to the IP address for Server B. All of your users are now automatically and completely seamlessly directed to the healthy Server A. The outage is contained. And your users, they probably never even knew there was a problem. Now, this automatic rerouting, this failover, it generally comes in two main flavors. You've got active-active, which is what we just saw. All your servers are working, and if one gets sick, it just gets pulled out of rotation for a bit. Then there's active-passive. That's different. You have a primary server doing all the work, and a secondary, standby server just waiting on the sidelines. It only kicks in if the primary fails. That's absolutely perfect for disaster recovery scenarios. So when you start putting all of these pieces together, you realize this isn't just about a neat feature. You start to see a fundamental shift in how you think about building and operating your applications. And this is the payoff. This is why all of this matters. You move from being reactive to being proactive, spotting issues before your users ever do. You get automatic recovery, which means no more of those 3 a.m. panic drills. All of this leads to way higher availability and ultimately a total shift in your mindset. You are no longer just building applications that run, you are designing them from day one to survive failure. You know, there's a saying that I think just perfectly sums this all up. It's that good applications are built to run, but great applications are built to survive failure. Building for failure isn't being pessimistic. It's what separates good engineering from truly great engineering. It's about expecting things to break and having an automated, graceful plan for when they do. So I want to leave you with this one question to think about for your own critical systems. Take a hard look at them. Are they just built to run, fingers crossed, hoping for the best? Or are they truly built to survive?